Welcome back. Good evening, all of you. And first of all, I would like to welcome to all of you to join this workshop, which is based on mathematical practicals by using open source and free softwares. So, as you know, the computing play a very important role in the development of science and technology, and for that we need some softwares. And there are various type of softwares available in the market. Some of are open source and some are commercial softwares. Mathematica, Maple, MATLAB, etc. These are the commercial softwares, and to use all these, we need to pay, and then we need to purchase the license. Then after we can use for our scientific computing. But on the other hand, there are some open source software like Python, R programming, Scilab, etc. So these softwares we can also use for scientific computing. And as you know, these days in the Python play a very important role because this is the one of the most popular language for the software, which is highly used for the scientific computing. And all the peoples are going to shift to use this software. Since the main reason is this is open source, free available, and there are several libraries. By importing all these libraries, we can easily use and take very less space while computing. And also it has the very large community, and they are integrating various type of the tools, libraries, and easily we can have support from the community. Okay, so various reasons are there. So in this workshop, we will use Python. And also to use the Python, there are different interfaces by using, we can do some experiment after installing the Python in our system. But there is one more problem. Sometimes if we need more support and we want that our data and the findings which we create must be saved in our system, and for that we can use the same thing in cloud computing. So there are several cloud computing interfaces are there. Without any installation in our system, we can use Python for different findings, computing, and many more. Also, I would like to permit you to unmute your mic during the discussion. If you have any question, you can unmute your mic or you can raise your hand. So during this session, what we do, we will use Google Colab. Google Colab is provided by the Google and interface. And the most important thing is that we need not required to install Python or any other library. Since when we start to use this Google Colab, the several libraries which are required for scientific computing, machine learning, data analytics are available in Google Colab. So we are not required to install the basic libraries. If sometime some specific library which is not installed in Google Colab, we can also install in the Python by using Google Colab. So this is very user friendly, and before using this Colab, I would like to have some basic introduction about Google Colab. Why Google Colab is important and how we can use. So we will start this session from the very basic level, and everyone, whether you are familiar with the programming or not, all the things which I will cover during this session, all will be very hands-on, and also the content which I prepared or which I will present during the session, you can easily access, or I will provide you. Okay. And how you can access, I will let you know at the end of the session. So you need to stay connected during this session. And I hope that at the end you will be very familiar and all the things which we will cover will be very supportive to all of you. So the Google Colab, shortly we can say Collaboratory is a cloud-based platform developed by Google Colab that allows users to write and execute Python code in a Jupyter Notebook environment. So the code which we will write and execute in the Google Colab, you can execute the same in the Jupyter Notebook. So in the beginning, you will be a little bit confused about the Jupyter Notebook or the Colab. Don't worry. When we will start to use, then you will be familiar about this. Okay. And it is particularly popular for machine learning, data analysis, and other computational tasks, offering access to powerful GPU and TPU for free or at the low cost. There are some key features of the Google Colab, which will include no setup required. It runs in the cloud, so there no need to install Python or any library locally. Free access to computing power. Colab provide free access to CPU, GPU, and TPU, making it ideal for tasks like training machine learning models, etc. Also, multiple users can collaborate in real time on the same notebook. Sometime when we have the very big project and we have a very long programming, in that case, we can do or we can write the program collaboratively, and also the peoples can remotely collaborate with the same task. So this is the beauty of this Google Colab. And when we will start, this will be very hands-on and very simple to use. Also, we can easily save and share our project through Google Drive. So all the content which we will create, we will develop or we will write several type of the, you can say, project. All these we need not require to save. All these will be saved automatically in our Google Drive. So all the things which we will do during these 2 hours, I will show you, and how you can create your file, how you can access in the future, okay, and where this file will be available. So now I would like to share my screen, and then we discuss everything one by one. And I hope that this will be very informative, knowledgeable to all of you. So once again, welcome to all of you and showing your interest to join this 2 hours session. So now I am going to share my screen, and during the discussion, if you have any question, please don't hesitate. You can raise your hand or you can unmute your mic. Otherwise, also you can put your query in the chat box. Okay, so this is completely a friendly session, and I hope that you will accommodate with me. Thank you. So now I am going to share my screen, and please let me know if my screen is visible to all of you. You can see my screen. A recording not required because this is
Yes,
also the live streaming. This is live stream, so recording not required. Okay, the link where the recording will be available will be shared with all of you. You can access it anytime. So at the end of the session, I will let you know where you can access the recording of the session. Okay, so what you will do to start your task on Google Collaborate. So the first important thing is that you must have your Gmail account. Okay, so if your Gmail account is login, as you can see that this is my Gmail account, and all this my Gmail account is login at this place. and you can see all the emails are here at this place. So the important thing is that your Gmail account must be logged in, and then after, what you will do, you just write at this place Colab. You will write here Colab, and you will find here Colab or Colab Google. So you can select one of them. Okay, I click on first one. So as soon as I will click, you will see that on the top, welcome to Colab. So this is the link of Google Colab, okay, which will be the official URL is colab.research.google.com. Okay, just you need to click on this link. You need not required to install anything. Just you must have your own Google account, and just you need to search in Google Colab, and you will have this URL on the top. Click on it. So as soon as you will click on it, you will find that this is the interface, and several files are available, because I have many files has been already created. That's why this interface is looking in this way. You don't have these files, so you just need to click only on new notebook. So as soon as you will click on new notebook, so Google Colab new notebook will open. It will take a few seconds. Yes. So this is the interface, or the interface of the file, which is based on Jupyter notebook. Okay. Jupyter is also one of the IDLE for the Python. And this file is also based on Jupyter notebook. The extension of this one, you can see, I see at the end of which the part I highlighted at this place, IPYNB. Okay. So this extension is also in the Jupyter notebook when you will save the file. Okay. So the file which you will create in the Google Colab, you can easily download this file, and you can use the same file in Jupyter notebook. You can also use the same when you will install Python in your system. Okay, so at the end, I will explain everything how you can download, but currently we will use only Colab, and at this place, I will explain everything how you can create this file, how you can write your text, how you can write your code, how you can execute. Okay, so see, first you need to rename the file. Okay, so I will give the name workshop on mathematical practical. I give the name of the file as this one. Okay, so this is the name of the file. After that, you can see here we have plus code and plus text. So first, you are creating the file which will have many things. Sometimes you need to give the description, you need to give the title, what task you are performing. There are several cells, okay, everything. So when you will click on it, here you will enter the workshop. Title here is workshop on mathematics practicals. Okay. So as soon as I type at this place, on the right hand side, you can see the same. If you want to bold this one, just you need to select and press this bold. You on the right hand side, you can see the text which I type at this place are now bold. If you want to increase the font size, you will enter hash. And you can see on the right hand side, the font size has been increased. Okay, so this is the name of the file and title. what we are doing here. Okay. If you want to insert here some more, when you will, if when you will enter, the cursor will be in the next line. Okay, you can give some more description. We will add here some basic operations of mathematics and plotting. Okay, so you can give this description about, and you can extend according to your requirement. Okay, so when you will press control and enter, when you will press here control and enter, shift and enter, sorry. So when you will press shift and enter, now you can see there is one more shell which is above, and this is at this place. So title must be on the top. And at this place, you can see one is upward arrow sign, other is downward arrow sign. So when you will select this shell where we have the title text shell, okay. So you can move by pressing this one. So this is the on the top, okay. Now this part where we can write the code, okay. So here we can write the code. Okay, so here you can perform some experiment, say basic operations. If you are using hash, hash is used for comment. Comment is nothing but the description what we are going to do. Okay, so here you can do basic operations and then enter. Suppose that we have a is equal to 9, then enter. B is equal to 6, then enter. C is equal to, we have is again 8. C is equal to, we have is 8. And D is equal to, I have is 23. Okay, so here I have very simple statements. This shell will work as a calculator also. Okay, so for the assignment, we need not required to declare any variable. Just you can assign the values A, B, C, D or some parameters, and equal is used to for the assignment. So the values which are A 9 for A, 6 for B, 8 for C, and 23 for D are stored. Okay, and if you need or you want to perform some experiment on it or basic operations, you can do. See here, I am taking D. E is equal to, I have very simple operation. I have A plus B and plus C. Then I have minus D. Okay, this is the divide. Divide by, suppose that it is A plus B. A plus B. Okay, and then enter. Now if you want to print E. This is print E. Or simply you can write here only E. So when you will execute, how you can execute this shell, and also see here at the bottom you can see where my cursor is moving. The color is like brown. Okay, light black it is showing. So when I will run this code, you can just press from this place. Okay, and here you can see 3 dots which are now in orange color, and it is showing that it is connecting. So our file is going to connect with the cloud computing, and when it will be connected, you can see that now the sign is green. So when the sign is green, it means that our file is connected for cloud computing. Okay, along with, you can see previously this information was not available, but now we have connected to the Python 3 Google Compute Engine baked. Okay, and RAM is 12.67, but we are using only 1.12 GB. Okay, and disk space you can see here is 107.72 GB, and we are using, or we will use only 32.82 GB. Okay, so this space Google Colab provide free, and speed is very high for the computing, because usually what in our system we have 4 GB RAM or 8 GB. Okay, so here 12.67 GB is provided by Colab. So this is the important information, and you can see here the basic result we have is only 0. If you want some more experiment, you can edit the files. If you will divide by 5 and again execute, you can have frequent reply a plus b plus d. I think it becomes, you can take here plus d. Okay, now yes, it is 9.2. If you have, if you are taking at space a b, okay, when you are using the product sign 2 times, it means this is the exponent. This is the exponent. So here I am taking the value of a is 2 and that of b is 3. So a exponent b will be equal to 8. Execute the file. Yes, the value which is returning at this place is 8, because this is 2 and the value of b is 3. The meaning of this expression is a raised to power b, a exponent b. That's why the value which is returning at this place is 8. Okay. Again, if you want at this place text, okay, you need to select this one, and again you can type here some text at this place. Okay. So I think this is very clear. Okay. So if again you have, if any some more statement you can do here, you can write here uh, uh, Python is calculator. Okay. So, and then press and enter. So here you can directly compute everything, 23 plus 90 plus 89. And when you will execute, this will return the value. Okay, if you want to divide, so all type of the basic operation you can perform here very easily. You can check it. Okay, now this is the way how we can create the file and how you can save the file, how the text are being generated here. Okay, so everything which we need, how to write the code, how you to run the code, and how you can enter the text. Okay, so now this is the basic information about the interface. Okay, also see here, you can locate the file, and here you can see open in playground mode. You can open new notebook. When you will click here, new notebook will open notebook. If you have any file in your drive, you can open the same. You can rename, you can upload notebook. If you have any file and you want to upload, just you need to click on at this place, and then you can browse from, you will click here, and any file which exists in your system. See, I have this file. Okay, and in this you can see several files are there. I want to import any file. See, I am taking this file and open. So this file will upload in our Google Drive, and then after you can use. Yes. Yes, you can see this is the file, and from this place you can easily execute. Okay, you can execute the file, just pressing this one. Okay, so the file is going to connect, and it is connected. Now you can execute. This is the string. Then you can extract. So this is the other part. I will not go through more detail about this file. Okay, so in this way you can install the file, upload the file, and you can use for your task. Okay, so now where is the file? The file which we create, and by default it has been removed from this place. You can easily access. You will go to Drive, click on it, and then you will go to My Drive. So when you will click on the My Drive, you see that there are several folders, but as soon as you will work start with this Colab, automatically this folder will generate in your Google Drive. So all the files which you will create will automatically saved in this Colab notebook folder. Okay, this folder will automatically generated in your Google Drive. And from that place, you can easily access. And the file which I create now, you can see. Yes, this is the file which we create during the starting this session. And as soon as you will double click on it, the file will open, and the content which we create are available in this file. You can see. So as much you will work, all the things will be saved automatically. And whenever you will open, all the things will save in your this file. Also, you can open from anywhere, but only by using laptop or personal PC, not in mobile. This file will not open your mobile. Okay. So now for today's session, I have created one file. You can see this is the file which I create for you, and many things we are going to cover during this session, and the content which we are going to discuss today during this session. So here, these are the practicals. Okay, these are very basic practical, and we can extend everything for our findings. But most of the participants are very beginner, and how we can do all these experiment. These are very quite simple as well as interesting. Okay, so here we have several functions: square root ax plus b, modulus of ax plus b, exponential rest ax plus b, sine ax plus b, sine modulus of ax plus b, cosine ax plus b, and how we can plot these functions. Then how we can plot the straight line, conic sections, draw circle when center and radius are given, and how we can draw circles when the center and any point on the circle are given. So all these we try to cover during the session, and many things are there, but we have to start how the Python will work. Okay, so here this is the very first example, and I would like to explain everything one by one. Okay, see, first we need to require libraries which we need to plot the graph. So there are two libraries. One is NumPy, and second one is matplotlib.pyplot. Okay. So why these two libraries are required? When we want to plot any function, we need some inputs. Okay. We need some input, and corresponding to the same, we need the values of y. See here, if x is input variable and y is some function. So for corresponding to each value of x, we need y array also. Okay, so we need these two arrays. One is x array, other is y array. And y array is depending upon the values of x. Okay, so for these two, we need two libraries. What is NumPy? NumPy is used for numbers, just like we required line space. Okay, line space from one particular interval, say minus a to b or minus a to a. Okay, minus 5 to 5. And we need to divide this interval in several points, depend upon our choice. So this type of the number operations, we can do perform by using NumPy. Okay, with the help of NumPy, we can generate arrays, series, and many more. And this will help us for the plotting. Now for the plot, for any plotting or to draw the graph, we need required matplotlib pyplot. This is the library which is used to visualize the result. Okay, but as well, you know, we need not required it to install NumPy. Okay, because NumPy is already installed in the Colab. Just we need to import. So the tools, the most important thing in the Python is that the several libraries are there, and only the library which required for our task we need to import, and others which are not required we can uninstall them. In this way, the Python took very less space in system when this is installed. Okay, so also as you can see, we are required only two libraries, and with the help of these two libraries, we can easily complete our task by using these two libraries. Okay, and also we import NumPy as NP. This is the just abbreviation. In the place of NumPy, we will use only NP. And similarly, you can see the name of matplotlib.pyplot as PLT. So in the place of matplotlib.pyplot, we have to enter many times. We use only PLT. This is the smallest abbreviation in the Python. Okay. So now these two libraries are required. First, we need to define the function. Okay. And our function is square root ax plus b. And for the plotting, we need to assign the values of a and b, which is very quite simple. So how we can define def? This is that we will start by defining the function as def, then fx. What is fx? Fx is sqrt is inbuilt function in the Python. Sqrt 3x plus 4. This is the function which is given in the example 1, under root ax plus b. Okay, but the same we are using here NP, because with the help of NP, we can generate array. So this will return in the form of array corresponding to the x input. So that's why we are using return np.sqrt. So when you will use NP and at every place you have to use NP, then the function or the other functions which we need to use. So the function by using NumPy, we can write in this way. Then we need to generate the x values. And as we know that square root 3x plus 4 will be defined only if when 3x plus 4 is greater than and equal to 0. Okay. So x must be greater than and equal to minus 4.3. So we will take the line space x is equal to np dot line space. Okay, see carefully. In the place of NumPy, we are using np dot line space. So this will generate an array. This will generate array. Okay, I will show you after the code how this will help us. And now we want to pass all these values through y is equal to fx, and fx is this function. Okay, so all the values of this array will pass through this function, and we have again y array. Okay, now we have two arrays, one is x and other is y. X is independent, y is dependent. Now we can think about to plot the graph. Okay, so for the plot, you just need only this statement and this statement. So PLT is the matplotlib.pyplot library, which is imported as PLT. Okay, then we will use the functions which are required for the plotting. Okay, so first .plt, this will plot the graph. This is the x variable, this is the y variable. X is independent, y is dependent. So x will be first, then we have y. This is the label R, and you can see square root 3x plus 4. Okay, then plt dot title. This will be the title of the plot. Then we have the x label. Okay, so you can see the information at the place lies in the quote. Okay, so all these are the strings. That's why we are using quote sign. Similarly, on the plt.x label, we have is x, and plt.y label we have is fx. plt.grid, grid is true. So this will generate the grid, and legend is also very important. And when we have multiple graph, then this will let you know. And when we plot the graph, then I will show you. And the last statement, which is plt.show, this will print the graph corresponding to the above inputs. Okay, so when you will execute this shell, pressing this one, and this is running. Okay, and you can see we have this graph. Okay, so here what you are observing, on the horizontal line we have x. This is the x level. Okay, and left to the graph we have is fx. This is the y label. On the top we have plot of under root 3x plus 4. This is the title of the graph. And here we have under root 3x plus 4. This is the legend. Okay, so if the color is blue, then this will be blue. If the color is red, then this will be red. Okay, so by this way, when we have multiple graph in the single plot, this will help us to recognize the graph. Okay, so in all type of the graph, all the statement which we discuss here, you can see only the thing which will change this function, or this may change domain. The other things will remain same. Okay, so this was the graph. If you want to manipulate, see, if I have this is 4. Now we have only 4 points in the interval minus 4 upon 3 to 10. And when I will execute, see the graph. Now you can see at the from this place to this place is one straight line. Then from this point to this point is other straight line. And this point to this point, we have the other part of the straight line. So there are three straight line segments, okay, which are connected with each other. And there are only 4 points. This is 1 point, this is a second, and here is third, and at this place, fourth point. Okay, so if the step size will be as much small, you will have the smooth curve. Okay, if you will increase 10, okay, now there are 10 points. This will be more smooth. If you will have here is 100, okay, so as much you will increase the number of steps, our graph will be more smooth. So you can see this is the more smooth graph. And if you will increase more point, okay, so and to increase the more point means the step size is small. So as much the step size or the increment will be as small as possible, our finding the graph will be more smooth. Okay, so in this way we can do several experiment for the different type of the functions, and also this will help you if you have any kind of the findings, just like solving the differential equations or solving the partial differential equations or other type of the function which you need to visualize the result. This all these statement will help you to visualize your findings. And otherwise, if we have any kind of the function and we want to study the nature of the function, this can be possible only if you visualize the functions or the findings. This will help us to understand the nature of the function. Okay, so here you can see the change in the graph is x is going to increase and how the function is increased. Also, you can change these parameters at the place of 3 or 4. You can manipulate these numbers and you will have several experiments by using the same program. Similarly, you can see here, this is the second example, modulus of ax plus b, how you can plot this graph. Very simple. As I told you that these are required in every statement, just the function will change. Okay, here we have modulus of 3x plus 4. How you can define the function? Very simple. Def fx, this is the same statement. Return np dot. For modulus, we have absolute function in the Python. This is inbuilt function, abs. And then this is the input argument. And argument we have is 3x plus 4. So only by using these two statements, you can write your function. And then after we need input corresponding to the interval, which interval we need. So I am taking here minus 10 to 10. So corresponding to minus 10 to 10, I have to generate the line space. And this is the same statement, only the parametric values changed. Okay. And again, you can say this is the y function. Y is equal to fx. We need to calculate values of y corresponding to x. Okay. Then we create the plot. This is the again same statement, only what is the change you can see? The statements and the functions which we are using here are same. All these are same, but only the function replaced. Here is modulus of 3x plus 4. Color B. B is used for blue. Okay. Then we have the add the titles. We have title. Then we have X label, Y label. Okay. Grid, true, legend. And then to show the graph, to show the plot, we have plot plt dot show. And so as soon as you will execute these sequence of statement, and you can see we have very beautiful graph. This is very beautiful graph. Also, when you will press F11, you can increase the size of the file. This is the full screen you can see by pressing F11. So you can see this is very beautiful graph of modulus of 3x plus 4. Okay. So very frequently you can plot several type of the graphs. Again, we have e raised to power ax plus b. So only one thing will change, and that is function. The other statement will remain same, or you can manipulate the domain. Okay. So here you can see everything. Import numpy as np, matplotlib.pyplot as plt. Then we have the function def is a function x return np.exponential. This is e raised to power 3x plus 4. Okay. And the interval we are choosing here minus 2 to 2. The x value is the line space, and y value is the function. Okay, for the function, we choose, you can see one more thing I need to explain here. In the previous, we are using only f, but here I defined by using function, func. So the same you have to use at the place. Syntax are very sensitive, so you have to follow this syntax. Don't make any error, otherwise your code will not run. Okay, so x value will pass through this function and then plot the graph. These are the x values, these are the y values, then label, and after that we have plt, x label, y label, title. All these are same statement. Okay, so when you will execute, and if you want to increase the font size, you can do also control shift and plus. You can see the font size increased. Again, you can see font size has been increased. Okay. So these are the sequence of statement. And now I need to execute all these sequence of statement, and your cursor must be in this shell. Okay. And press here. You can see we have the graph. This is the graph. And if you want to decrease the font size, control and minus, control minus. So you can decrease the font size. This is the graph of e raised to power 3x plus 4. Okay. Similarly, you can do for sine ax plus b. So here we have is sine 4x plus 3. Okay. The other thing minus 1 to 1. And here the point we are choosing 1000, not required all this. Decrease the number of, increase the step size. Okay. So the other statement will remain same, and you can execute, and we have the graph. You can see this is the sine 4x plus 3. Okay. And if you have only x, okay. Yes. And then so this is the minus 1 to 1. We can increase the value, say minus 10 to 10. This is the sine graph. Okay, minus 10 to 10 sine graph. Minimum value is minus 1 and maximum value is 1. Okay, you can see. Similarly, you can have the sine modulus of ax plus b. Only the function will change. Only the function will change. Just a moment, I have to update this file so that when I will share with you, you don't have any issue. 3x plus 4, use here product sign. Yes, it is fine. And for the modulus, sine modulus of ax plus b, see only this part. This part is only important. NP dot sine, NP dot absolute 4x plus 3. See the syntax very carefully. Only this part is important. Okay. So the other statement will remain same. X line space we are tracking minus 10 to 10. Then you can manage the size of figure size also. Okay. So here the first statement you can see figure size PLT dot figure. Fig size is equal to 8 by 6. 8 will be the length and 6 will be the height. Then plot the graph, and here is title, X label, Y label. Also here some more information. See very carefully. PLT dot AXH line. This will enter the horizontal line. AXH means horizontal line. Axis, AX for axis, H for horizontal line. Okay. Where at the point 0. Color black, line width 0.5. Similarly, we have PLT dot AXV line. V means vertical. Okay. Where when 0 at the point 0. And the color is black, line width is 0.5. And also you can see here grid. Okay. And the legend, then we have PLT dot show. When I will execute the sequence of statement, and you can see there are some participants who are attending the session online through live streaming. All those participants, you can put your questions in the chat box in the live streaming. Okay. If you have any question, I will try to justify your questions through the chat box. Okay. So once again, thank you to all the participants who are attending the session through live streaming. So when I will execute, you can see this is the graph. And you can see here this line. This is the black line. Okay. And also we have the vertical line. Vertical line is at the point 0. See here. See carefully, when we have is x0, at this place we have vertical line. Okay. And when we have y is 0, so we have the horizontal line. Okay. And also we have the legend. This is the legend which is on this line. And this is the title. And on the horizontal line we have x, and vertical line we have y. So due to these two statements, these two statements are new. That's why we have the horizontal line and vertical line. Okay. And also see here grid, true, which both horizontal and vertical, line style, dash dash, and line width 0.5. You can see in the graph there are some vertical and horizontal lines which are making grid. Okay, you can see. And this was manipulated by using this statement. Okay, by using this statement. Again, in the same way, you can plot the cosine x. This is the same way. If you have someone is asking in the chat box, how can we get those software application? Okay, and yes, we can add the sliders for parameters. Yes, we can do everything which we can do in the MATLAB. Also, the important thing is that Python can be integrate in MATLAB and vice versa. Okay, so the syntax are also spotted to each other. Everything which you can do in MATLAB, you can do in the Python also, and comparing the syntax of the MATLAB code. Abdul Wakil, can you please kindly assist us with the link to download all softwares to be discussed? Dear Abdul Wakil, we need not required to download the software for this session which we are discussing. The files which you can see here are based on Jupyter Notebook. Okay. And we are using Google Colab. So when you are using the Google Colab, you need not required to install Python. Just you need your Google account, Gmail account. Gmail account is sufficient. So at the end also, don't forget to ask this thing. I will again explain because some of the participants joined the session later and some initial part missed. So I will again repeat the same thing after the end, during the end of the session. Okay. So don't forget to ask this query again. I will let you know how you can do everything without installing any software in your system for Python. This is completely based on cloud computing, which is provided by Google, and collaborator is Google Colab. Okay. Similarly, you can see here, this is the line plot. This is the line plot. Okay. And here we have is, okay. Here you can see, see carefully, import numpy and matplotlib.pyplot splt. These are the libraries which are required, and in every case for plotting. Here we need to define y is equal to mx plus c, and you can see y depend upon one variable and two parameters. Okay, so in our function, we have the straight line function x comma m comma c, and which will return m product x plus c, this part. Now we are taking the line space, which is from -10 to 10, and we will divide up to 400. Now we for the different values of m and c, we have different plot. Okay, so see here, this will be the multiple graphs will be plotted. For example, you can see here the value of m is 1 and that of c is 0, and label we are, this is the label. See carefully, label in the quote sign, this is the string, then again colon r, quote sign, sign of dollar for mathematical equation, m equal to 1 and c equal to 0. Similarly, for the second line, we are taking, because for the different values of M and C, we have different lines. And according to that, we choose several examples, and all these will for different values of the M as well as for the C. Okay. And these are 5 examples. Okay. We choose here for different values of M and C. So when after that, we have PLT dot figure size, and then for example, in examples, y is equal to the straight line. We have to pass these values of M and C, okay, through the straight line function. Okay, this is a straight line function. X is the input argument, and this is the examples, and we wanted to pass all these values for M and C. Okay, so this is the you can see this part very carefully. This statement for EX in examples. Okay, where EX square bracket M then comma EX square bracket inside cosine C. Okay, so when you will enter corresponding to all the parameters, we have several arrays for Y, and PLT dot to plot X comma Y comma label equal to example labels. Okay, so corresponding to all these labels will be available in the graph also. Then after, we need to add the title, X label, Y label, as you can see here. And further, if you need to insert grid legend, okay, we are using legend left LOC, left corner, okay, and PLT dot AXH line and vertical line, as we do in the previous example, PLT dot show. So here you can observe that we have several graphs will be plotted in the single graph. And when we will execute all these sequence of statement, yes, you can see we have multiple lines in the single graph. And corresponding to all these graph, we have the legend. So this is the blue color, and the line for y is equal to mx, m is equal to 1, and c equal to 0. We have this line, and you can see that this line is passing through the origin. Okay, because here c is 0, that's why this line is passing through the origin. Similarly, you can see y is equal to 2x minus 1, where m is equal to 2, c equal to minus 1. Okay, see this line. So here, this line, orange color. Similarly, you can check green, red, and magenta color. Okay, all the lines have legend, and with the help of this legend, you can recognize the lines. And on the horizontal line, we have the X label, and that of Y, we have Y label. On the top, we have title. If you did not ask how you can save the file, very quite simple. What you will do, just right click on it. You will right click on it and then save image as. Then you can give the name. You can give the name figure 1. Okay, this is figure 1. So this will save and will be available in my download directory. Okay, again, you can come to, these are the Conics, very long program I will share with you. 2 examples I would like to discuss right now. Practical 4, to draw the circle when the center and radius are given. Again, very simple. We want to plot we need to import here matplotlib.pyplot and not required numpy, since we have x as well as y input, both are the input argument for the circle. So here you can see definition, draw circle, x center, y center. So these are the x values of x and y for the center and radius. Okay, here center is given, radius is given, then plot the graph. Very simple. So here figure ax is equal to plt dot subplot, we will be there. Circle, this will generate the circle. See this statement very carefully. PLT dot circle. So PLT is the graph, and inside there is a inbuilt circle function. We are just using the function from PLT. And here you can see these are the input argument for the circle, x center, comma y center. Then we have the radius. The color is blue, fill false. Then add the circle to the plot, because here we have the subplot as well as we have this part also. Okay, so we need to add the circle to the plot. So ax dot add underscore page is used to add the plot, and this circle will be saved in this argument, and we need to pass this argument at the place. After that, you can define the limits of the x-axis and y-axis. So here we have ax dot set underscore x limit. Okay, so the limit is x center minus radius minus 1. Okay, and x center plus radius plus 1. So this is the left side and this is the right side. Similarly, you can set the y limit. We are doing here y center minus radius minus 1 and y center plus radius plus 1. And axis aspect we have to fix equal and box. Okay. Then display the plot, plt dot grid true and plt dot show. Okay. Now these are the function code, and we need to pass the values through the function which is defined at this place. Okay, so this is very quite simple, and function is draw circle. These are the input argument 3, 4, 5. Okay, 3, 4 is the center and 5 is the radius. And when you will execute, we have the circle. We have the circle. Okay, when center is given and radius is given, if we have this is 0 and this is also 0, and when you will execute, now you can see that the center of the circle, this line and this line close at the place. The cursor is now center of the circle. If you make at this place 5 and run the code, now you can see the center of the circle is at this point, because x is 0. Sorry, x is 0. Okay, but y is, this is the value of y. Okay, y is at this point, and radius is also 5. So you can manipulate with the different values of the input argument for the center and radius. Okay, so this was 3 and 4. So once you write the code, you can manipulate, you can play the code, and quite simple. Again, if we are given that, if we are given the center and point on the circle, see the statement. To draw circles when the center and any point on the circle are given. So how we can write the code? So now we have 2 points. One is the center and other is the given point of the circle. Okay. So see, import matplotlib dot pyplot as plt and import math, because here we need to take the distance between 2 points to find out the radius of the circle. That's why we need to import math also. Math is also a library in Python for mathematical operations. Okay, for mathematical functions. So at this place we need math library. And the function which we will create here is very quite simple. Draw circle with a point. So see the input, we are given the center and we are given the point. So x point, y point, and x center, y center. These will represent the center, coordinate of the center, and the other two will represent the coordinate of a given point. Then to find out the radius of the circle, we need the distance between the given coordinate of the center as well as the coordinate of the given point. So we are 2 points. One is center and one is single point for the circle. So here, this is the formula math dot sqrt, square root of x point minus x center square, okay, plus y point minus y center square. So this is very simple, x1 minus x2 square plus y2 minus y1 square, and it's a square root. This is the distance formula. So we are using here distance formula for radius. Other statements are very quite simple. So first we are taking the figure x plt dot subplot, then the circle, and see the input argument. We have plt dot circle, okay, x center minus y center, center are given, and here radius was not given. Radius was not given. In the previous example, we have the radius, and this statement is same as we do in the first example, but the new thing is this statement. Okay, radius. So radius will pass through at this place. The other remains same. Other are same statement. So here you can see at the page, add the circle to the plot. We are using add underscore page circle. Then we have the plt dot plot, x center, y center. Then we have plt plot, x point, y point. This is the red color and this is the in the blue color. Okay. So these are also required, the where will be the center and where will be the given point. Okay. So we can fix the x limit, y limit in the same way. Then plt grid true, legend, and plt dot title, and after that plt dot show. Okay, so this is the entire programming for the function when we are given center of the circle and point on the circle. Now we need to pass 2 points when we are given center of the circle. Suppose that it is 2 and 3, and the point on the circle, it is 6, 7. So see this is the function, draw circle, with point, and 2, 3, 6, 7. First two are the center of the circle, other two are point of the circle, point of the circle. Okay. And see this function which we create, and we pass all the argument at this place, and when you will execute, we have a very beautiful graph you can observe at this place. So here you can see horizontal line and vertical line. Red color is the center, and blue color point on the circle. Okay. 2, 3. 2, 3 is this is the 2, 3 point, which is the center, and 6, 7. 6, 7, you can see the value of x is 6 and that of y is 7 in the middle of 6 and 8. Okay. So everything according to our desire, you can observe in the graph. So this is the some experiments how we can plot several functions, and this content which I present here, I am sure will help you to plot different type of the functions. And also when we are solving some type of the differential equations or mathematical models, or we have the database, everything. So the statement which we use for the plotting, most of the statement are similar type, only few changes are required for different functions. So the code which we write here are simple as we speak in English, and the syntax are same as we speak. Okay. So this is the few examples, and if you will press F11. Okay. Now you can check this figure. When I will double click, you can double click at a place, or either you can go to my download. This is the download, and here this is the figure 1 which I download. When I will double click on it, you can see this is the graph. Okay, you can see here, this is the graph. Okay, so this is the way of the plotting. And if also, sorry, if you have, yeah, we have 30 minutes more. I will demonstrate one more example for you. We can mathematics, data science. Yes. So all type of data analysis, machine learning, and many more, we can do everything by using, here is the mathematics for data science. Okay, is there some examples? Yes. We have some examples. Okay, so also you can see here, we are using creating vector and matrix, how we can do. So for that, we are using again NumPy as NP, and how we can create the vector. See, this is the example. Vector is equal to NP dot array. Okay, so this is the vector and having the element 2, 5, 7. And how we can print this is the statement to print vector, and the statement the input value which we give at this place will store in vector and will pass at this place. And when we will execute, which is based on mathematical radicals by using open source and free source, store in vector. Just 1 minute. Just 1 minute. What happened with me? Okay. Okay. So this is the Jupyter interface. You can see this is the Jupyter notebook. Okay, when you will install Anaconda or Jupyter notebook in your system, then this will look like in this way. The code will be same. Okay, this file you can use in the Google Colab also. So here I have cut all this file and see when I will execute, first this file will connect with the Colab, Google Colab, and then after it will run. Yes. So this is the vector. You can see this is the vector. Okay. So the other statement which I have. So here you can see vector addition, vector plus one more vector we are adding, np.array. The element are 4, 5, 6. So this vector will be added with this vector. Okay, see. Now we have two statement, and when I will execute, yes. So this is the vector addition. So here you can see 2 plus 4, 6, and 5 plus 5, 10. 7 plus 6, 13. Okay. Again, you can have the scalar multiplication. Then you can see this is the dot product. Okay. NP dot product vector. This is the first vector which we generate here. This one. And the new vector NP dot array 4, 5, 6. So we can easily calculate, compute dot product. So this will return the dot product. And this will return the magnitude. And for the magnitude, you will use np dot len alg dot norm. Okay, norm is the magnitude of the vector. Okay, so you will use np dot len alg. Okay, and when you will execute, we have all the values corresponding to all these. So here you can see the dot product of these we have is 75, and the magnitude of the vector we have is this one. Which vector? This one, which we choose in the very first. This one. The magnitude of this one we have is this value. Okay. Similarly, you can generate several vector. You can find their addition, subtraction, multiplication, all the basic operations you can perform very easily. So this is the first vector. This is the second vector. And vector sum will be equal to vector 1 plus vector 2. And this is the way to 8. And this statement will print the sum of the vector. Okay. So this is nothing but the string. String means just like we speak. Okay, like just like Meher Chand, my name, or any statement, any word, just like vector sum. And this is the value which will convert in the string, and the value will which is computed at in this statement will pass at this place in the form of a string. Similarly, we have the matrix addition. How you can write the matrix by using NP, NumPy. So this is the first matrix, np.array. So this is the first row. This is the second row. This is the third row. Okay. So this is the left bracket and this is the right bracket. Similarly, we have the second matrix and this is the sum of the matrix. Okay. So first we will discuss these two. Yes. So you can see this is the vector 1 and this is the sum of the matrix. This is the sum of the matrix. Okay. Here we print the sum of the matrix. So this is the value which is sum of the two matrix. If you want to print if you want to print the matrix, say matrix 1. Okay, just we need to pass here. And when you will execute the last part, this is the matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the first row. This is the second row. This is the third row. Okay. And here we have the scalar multiplication of vector 1. This is the scalar multiplication to the matrix 1. Okay. And both are printed at its place. Okay. Remove this one. So by using the NumPy, you can easily generate matrix in this way. And here are the dot product and matrix multiplications. These are also again very simple. This is the vector 1 and vector 2. Okay, you can find the dot product by using the dot function like in this way. NP dot vector 1, vector 2. This will return the dot product of these two vectors. And this statement will print the value. And if you have the matrix, two matrices, this is the first matrix, NP dot array. This is the matrix of 3 by 2 order. 3 rows are there. You can see these are 3 rows and 2 columns. And here you can see 2 by 2 order. And dot product of these two matrices, NP dot, we have matrix 1, matrix 2. Okay. And print. This statement is used to print the product and matrix underscore product. So when you will execute, yes. So the first is the dot product of the vector, and the second one we have the matrix product. And also for the transpose, you can see if you need to find out the transpose matrix, that is also again very simple. And all these statement and functions which we are discussing here, highly useful and in the data science, data analytic, machine learning, when we have large database, so we can use all these functions which we are using because the database is itself in a matrix form. Okay. So the operations which we are doing here also again will help you in the data science. So matrix algebra play a very important role in data analytic data science. So here you can see this is the matrix and NP dot transpose. This will return the transpose matrix and will store at its place, and we can print here transpose matrix. Again, if you want to find out the inverse matrix, inverse of a given matrix, then what you will do, you will use NP dot lin elk dot inverse matrix. So two examples are there, one for the transpose and other for the inverse matrix. When you will execute, you will have the one is transpose matrix and other is inverse matrix. Okay. And if you have the system of equations like 2x plus 3y is equal to 5 and 3x plus 4y is equal to 6. If you want to solve this system of equation by using the matrix, but with the help of Python, you can do. So first we have to convert this system of equation in the matrix form. Okay. So A matrix will be the coefficient of xy from these two. So these are the coefficient of xy in the first equation, and these are the coefficient of xy in the second equation. And B is equal to NP dot array. These are the value of 5 and 6 on the right hand side of the given system of equation. Okay. And then after we have solving the linear equation, that is also again very simple. Solution will be equal to NP dot line alg dot solve AB. So this will solve the these two matrix A and B. for the system of equation. Okay. And we need to print the value. So print solution xy solution. So when you will execute, see the result. Yes. So the first is the value of x and the second one is the value of y. So in this way, you can solve the system of equations involving multiple variable. Here I put only very simple example involving two variables. You can have three variable, four variable, five variable, and more variable. Okay, but the syntax you can extend for any number of variable by using this syntax. Okay. And then we have, okay, this is the example of the derivative. How we can differentiate? Okay. See this is the part of the symbolic mathematics. Okay. So when we have differential equations, differentiations, integrations, and after solving these, we have at the end again some function. So that's why we have to define the symbolic variable. And here we are using, see, SymPy. SymPy is the library which is used for the symbolic mathematics. Sim means symbolic and Pi means Python. Okay. Symbolic mathematics, Pi, Python. And combining these two, we have SymPy library. And we will import SymPy as SP. Okay. So SymPy is a symbolic mathematics library in the Python, and we can easily import, but here we need not require to install. First, we need to define the variable. Then we have the function f is equal to sp dot sin x product sp dot exponential. So here, these are the two functions. One is sine product exponential function, and we want to differentiate the function with respect to x. Okay, so the function is f and we want to differentiate f with respect to x. So f prime, the value will be stored in the f prime and this will print. And also if you need to find out the higher order, a second order, third order, 10th order, 100th order, you can do. Very simple. We are again using the same statement. You can see here, the difference is only that at this place we are using the number 10. This will return the 10th order derivative of the above function. And this statement is used to print the value. And when I will execute, yes, you can see this is the first derivative. And this is the 10th order derivative. Okay, here I have to use 10th order. 10th order. Okay, I need to update the, okay. And if you have at the place 2, then this will be the second order. So this is the second order derivative and this is the first order derivative. If you will have at its place 50, so this is the 15th order derivative. So that's why we required scientific computing, and you can see it. The values are returning very frequently because we have cloud computing as well as the RAM and size. You can see here we are using only 1.40 GB out of 12.67 GB RAM. Okay, and space we have enough. So, and the last example I put for the integration. This is the last example for the integration. This will be the same. This statement is the same. And for the integration, you will use sp dot integrate f with respect to x. Okay. And the value will be stored at a space. This will print the indefinite integral of f. Okay. and this is the definite integral. And for the definite integral, what you will do, see this part carefully. We want to integrate with respect to x, and the lower limit is 0, upper limit is pi. Pi is from sp. Okay, so 0 comma sp dot pi. So 0 to pi, we want to integrate this function, and when you will execute, so here are the values. So there is one more example solving the differential equations. What should I do? Oh, there are so many examples. So what I do, I will share all this content with you, and this is all about the today's session, which I want to present, and I hope that the content which I share with you are very interesting, very useful, and you will integrate all this content for your teaching, and I hope so, and I can expect from all of you. So this is the today's session. If you have any question, any query, please feel free to ask from me. And all the participants who are attending the session through live streaming on YouTube, you can put your question on the chat box also. Dear participant, you can unmute your mic if you have any question, please. Anyone, please, if you have any question. Ashpreet Kaur, Abdul Wakil, Anthony, how are you? Chandresh Mathurji, how are you?
Fine.
Okay, any question, sir?
जस्ट इसके इनमें कौन सी ये जो सॉफ्टवेयर है इनको डाउनलोड करने का और ये जो आपका वीडियो है इसके प्रैक्टिस करने के लिए हमें इसकी वो चाहिए होगी लिंक चाहिए होगा वीडियो सो दैट वी कैन प्रैक्टिस इट
Okay. You need video. So what you
या
will do, just again, I am going to share my screen. This is for all the participant. I know the participant will ask about the same. So what you will do, you will open the YouTube, see, and in the YouTube, you will search @MTTF2020. You will enter only @MTTF2020, or you can enter the name of the Mathematic Thinking Foundation. So when you will enter @MTTF2020, okay, and the channel will be, this is the channel. You will click here and you can see this session is now live. Mathematics based practical using free and open source software. Okay. Or either you can go to live. So all the live sessions which has been organized are available here. Okay, all these are the live sessions. So just you need to visit on this MTTF live, and everything, the previous lectures are available here. You can anytime access all this content, and open source, no advertisement. No ad will play on these lectures. Okay, so all these are live sessions, and these are the lectures which are uploaded. You can find here also. These lectures are important. There are several based on Python, by using R, by using MATLAB, okay, for artificial intelligence, data analytic, and many more. Okay, some useful tools also, just like how we can use AI to create power presentation. This is the lecture on the same. This is the lecture for the advanced programming techniques. So many things are there, you can easily find out. And also you can find the playlist. Here are the playlist of the important lectures. Okay. So here, these are the lectures based on biostatic, International Award, AI Tools, Academia and Research. This is also very important. These are very important lectures. This is the playlist for 2-week faculty development program on MATLAB. Okay, you can find various lectures are there. So all the lectures are uploaded here. You can find day wise. Okay, all these are very useful. And similarly, you can find various lectures on this platform. If you forget MTTF 2020, then just you need to go to YouTube, and on the YouTube you can enter here name of the foundation, MathTech Thinking Foundation. And when you will enter,
Okay.
so these are the Method Think Foundation lectures. Okay, all these are Method Thinking Foundation lectures. You can easily access.
Thank you so
Okay.
much, sir. Thank you.
Also one more thing, you can find my name, Dr. Meher Chand. Okay. This is my personal YouTube channel, especially for MATLAB.
Okay, it's great. It's great.
Yeah. So here also very important lectures, especially we upload for numerical methods, ODE, PDE are there, and numerous lectures are in the progress. And very soon you have all type of the solutions using MATLAB for mathematical problems as well as for the other problems also. Okay, we are creating the content, and all these will be very supportive. Any more question, please? Yes, any more question, please?
In future, sir, anytime if we are facing any problem, so should we contact you directly?
Pardon?
In future, if we face any problem in our field, can we take your help?
Yeah, you can take my help. You can organize any workshop, virtual mode in your institute for the student. You can organize the any kind of sport you need open.
Thank you so much. It's
Yeah.
very grateful for us.
We are always here to support you. And also one more thing I will let you know. One more thing I will let you know. Just 1 minute.
Yeah, please.
Yes. So here you can have mathtechguru.com. This is also method platform where many things are we organizing, and many contents are free available. Okay, see when you will visit here, and also open source content are available at this place. Yeah. So here you can find free, and some more content we are preparing, which will be free available. Okay.
LaTeX, LaTeX.
Yeah, this is the LaTeX for scientific documentation. Okay, open source free available. This is also free available. And these are the FDPs which we organize with the collaboration of, you can see, Purnima, Central University of Punjab, Baba Farid Group of Institution, Nexus University, and this is the MDTF. And this is also the International Faculty Development Program organized with the collaboration of City University, Purnima University, Sardar Patel University, Gujarat. Okay. So jointly we have organized many programs. Again, you can see this is the another International Engineering College, and MTTF is there. RTU, Rajasthan Technical University, is also there.
Very good. Very good, sir.
This is also again recently we have organized FDP, ICFI University, and Morocco University, and MTF. Jointly, we organize this faculty development program. So many programs, recently we have created this platform, and also we have mobile app for this one. You can download the mobile app. We have right now Android mobile app. Okay. And free content you can easily access, and all the faculty development program we have organized. These will be now going to very soon open access, because these are now old event, but this will help for the STEM professionals, and very soon all these will be open access. Whenever you need the support from these programs which we have organized as a faculty development program, but certificate will not be awarded because the date has been expired, but for the learning purpose this will be open access. So this is the website mathtechguru.com, and when you will click here, you can go to our main website. This is the foundation MTTF official website, and all these things are organized by this foundation.
Sir.
Yes, please. Yeah, Ola Wale, you can unmute your mic.
Okay, thank you, sir. Please, how can we have access to the sample codes?
Pardon?
I say, how can we have access to the sample codes, the sample programs you showed?
Okay. You can register for these courses. The website I show you, mathtechguru.com, and you can download the mobile app, which is MTTF. I can share the mobile app also. Just 1 minute. I am sharing the mobile app. Yes. You can easily download from the Play Store, and copy link address. Yes. So I am sharing with you in the chat box link to download this app. Okay. MTTF, the name of the app is MTTF. You can easily download, and all the updates will be available in this mobile app. Okay. Also, there are several webinars which we have organized through this app, and all the content are open access, easily available. And, yes, please. So 2 courses are going to start, which will be open access, free available. You can register there, you can download. If you have the mobile app, then all the updates will be in your mobile, or either you can visit regularly on the website. Any more question, please? Okay, the file which I create for the today's session, I am going to share with you in the chat box so that you can do some experiment on it. Okay, see how we can download the file. This is also the important part for you, and how you can upload. So you can see, yes. So this is the file, and the other file, this one, which we covered during the session, how you can download. Okay. So here you will go to the file, click here, then you can scroll down, and at the place you will download, and you have 2 options. One is download.ipynb and other is py. If you have installed the Python in your system, then you will download this format. Otherwise, if you are using the Google Colab, then you will download this format. Okay, download this format. So this format will be downloaded in the directory. Current directory I have is download, and I will save here. And now I can share this link with you. If you want to upload and you want to use this file, very quite simple. What you will do, you will open your Google Drive, and in the Google Drive, you will have this Colab folder, Colab notebooks. Okay. This will create only if you will generate one file. Only then this folder will be available. And double click on it. So when you will double click on it, you can upload this file in this folder. So for that, new from this place you will upload the file, and now select the file. So this is my download, and this is the file which I download. Select the file and open the file. Replace existing file because this file already exists in my Google Drive. So I want to keep both. Upload. So you can see the file has been uploaded. And now when you will scroll down, the name is Mathematics Practical. This is the file which I just now upload. And when you will double click on it, this file will open in your Google Colab. This will open in your Google Colab and you can play this file. Okay, all the content are executable. There is no error. Okay, and one thing I will would like to let you know, that is how you can open the Google Colab. For that, you need only your Gmail account, and here you will enter only Colab. Then enter. This is the first link where you can find welcome to Colab. Just click on it. So all the beginners, just you need to click on new notebook. And when you will click on it, you will have notebook. Yes. So this is the new file which will open, and when you will create some content and you will execute, this file automatically generate the Google Colab folder in your Google Drive, and the file will this will be automatically saved in your Google Drive directory. You can access anytime. All the tasks which you will perform will save automatically at this place. You need not worry about the same. So all the things which we have discussed will be available in the recording, and I need to share the file with you. So you can, I want to share this file. Sorry. Just 1 minute. ये क्या हो गया? Okay. I have to file. Then computer. So you can download this file. I have shared in the chat box. If you need some more file or for more practice, you can contact me through WhatsApp. And my WhatsApp number is, there are some international participant, +91 978092 0053. So you can find my WhatsApp number, which is +91 978092 0053. So this is all about today's session, and I hope that the content which I share with you are very helpful, sportive, informative. And if this session is informative for you, and you want to express your gratitude, you can open your mic and share your experience about the today's session. Is it informative, valuable, or sportive for your, if you spend some time with me? Is this time fruitful for you, for your academic, and for your teaching? Yes, please. Anyone? I speak a lot. Now it is time to listen you. What do you think? Anthony, how are you? Dr. Anthony. Yes. I am not getting your voice. Manukamna madam.
Yes, sir.
How are you?
Fine, sir.
After
Great,
a long
sir.
time, I can listen to your voice.
Yes, sir. Yes, sir. Me also, sir.
Thank you. So how is going in your
Great
institute?
session, sir. I implement on this practical on to next exercise of my represent as a ICT tool, which we have apply on this our student for partial differential and many more for the
Okay.
R programming and also that is.
So I also let you know if you need any support from this foundation, like 1 day small workshop or webinar on any computing tool for mathematics, for machine learning, data analytic, this will be open and we will support you, anyone from any place.
Okay. Yes,
Yeah.
sir. I will definitely contact with you. Definitely.
Just you need to send the proposal and the event will be with the collaboration of MDTF. And for the 1 day webinar, this will be free support.
Okay, sir.
Yeah.
Definitely, sir. Thank you so much, sir.
Yes. So this will be help to our student, for our faculty members also.
Yes, sir.
And if anyone have required any support to organize virtual mode faculty development program, we are here to support you. Workshop, FDP, webinar, and very soon conference will be also there. Yes, any more? Arshdeep Kaur, Nedal, Hassan. Gurpreet Kaur ma'am, how are you? I think you are from Guru Kasi University, Gurpreet Kaur. If I am right.
No, sir. I am from Khalsa College, Ludhiana.
Okay, Khasa College from Jana. Yes. How are you, ma'am?
Yes, sir. All good, sir.
How about the today's session? Any suggestion?
Really interesting. No, sir. Everything was very good.
Any suggestion, please? Jasmeet Kaur. Okay. So,
Yes, sir.
Yeah. How about the session and how we can make changes so that the sessions which we organize in the virtual mode may be very fruitful, useful for you?
Sir, it was really helpful.
Any more?
Sir, I got more information about Python.
Okay.
Yes, sir.
So thank you to all to joining me. And if you have any question or the challenge, problem, you can contact me through my WhatsApp number. Okay, so I always feel free if you contact through WhatsApp. Sometimes I am not able to pick call, but if you drop your message, I definitely reply your message. So thank you and good night for today. Stay connected and enjoy these tools for your academic and teaching. Thank you.